Hello, hello. Welcome back to Hawkbar's Intro to Game Programming course. There we go. Intro to Game Programming course. Today we're doing session 1, which is Hello World and associated topics. Last week we walked over how to set up our programming environment, Visual Studio Code and .NET, and all the other programs we're going to need throughout this course. So if you haven't seen it already, look up the session 0 video on YouTube and walk through that. And then you can rejoin us for this session. So yeah, welcome. Let me pull up my syllabus. There we are. All right, so today we're talking a little bit about Hello World and what makes it tick. So hopefully, even if you're not a programmer yet, you can at least follow along with what this program is doing right here. You could ignore all of this. All you really need to see is these two lines. So this first line is telling the console to write a line of text that says "Hello World!" an exclamation mark. And then this line of code is telling the console to read a line, meaning wait for the user to type in a line of into the console and then move on. So fairly simple, but let's talk a little bit about kind of how this works behind the scenes in terms of how the computer works. So, a computer is made up of a couple major components. So you've obviously got the CPU, which is the brain of the computer, the most important part. I can't draw. Don't worry about it. There we go. It looks more like a Metroid than a brain. But yeah, CPU. And then you've got memory. Or RAM. Then we've also got disks, hard drives. HDD for hard disk drive. And then sitting between all of this is another chip called the bus. And in an actual computer, you've got lots of different RAM chips and lots of different buses. But for the sake of simplicity, we're just going to talk about it in terms of these main components. So the way a program works is you have a set of instructions laid out and saved somewhere on your computer. That would be what an exe would be. So for example, this intro to programming.exe file here is just a file sitting on a hard drive, taking up a certain number of bytes. And if I run it, it runs the program. The way that works under the hood is the file, wherever it's sitting, gets read off the hard drive through the bus and gets loaded into RAM. So now all those bytes that make up the file on the hard drive get loaded up into memory as bytes. And then the CPU somehow gets access to that file, and the operating system handles that part. You don't have to worry about it. But the CPU accesses the file within RAM, and it goes byte by byte reading each instruction and operating on it. So at a lower level, you can see what that looks like. So you can imagine RAM is looking like a series of individual bytes. Technically, yeah, it's individual bits, ones and zeros. And you probably heard frequently talking about how computers are ones and zeros. So you can imagine each of these boxes as a 1 or a 0. So on and so forth. So these ones and zeros get read off of the hard drive and loaded into RAM. And then the CPU over here and my mouse writing is terrible. Uses the bus to look up a certain address, a certain point within the RAM memory. Say, okay, so I'm going to read the next instruction from RAM. So it's got a pointer. So it's called because it points to a particular place in memory and says, okay, so I'm going to read from this point, and I'm going to read the next 8 bits or whatever. Depends on particular CPU and infrastructure, but basic idea is reads the next set of bits and gets sent back to the CPU. And then the CPU looks at those bits and it says, okay, well, this bit and this bit together mean this is like an add operation, for example. And then this bit is the first number we want to add. Let's say this is a 2, and these next 3 bits are the other number we want to add, and say that's 6. Yep, MS Paint diagrams. I'm a very skilled artist, as you can see. Not at all. But yeah, to explain how CPUs work. So the program gets loaded off the hard drive into RAM, and then the CPU accesses the program within RAM. And if it works, it works exactly. And then it reads a couple different bits at a time into the CPU. Hello, Moose. Good to see you. The CPU looks at the RAM, and certain bit patterns get handled by the CPU in different ways. So it'll look at these bits and say, okay, well, that means we're doing an add instruction. So we're gonna run an addition, and these are the numbers we're adding together, 2 and a 6. Okay, cool. So it takes all these bits, turns it into a specific operation that it has to do inside the CPU. And then it'll do that operation, it'll do the math, whatever, and it'll spit out that result somewhere. So in this case, this would be an 8. So it takes that instruction, performs it within the CPU, spits out the result somewhere. Usually that result gets put back into RAM somewhere. So the CPU might then say, okay, well, let's write that result back into RAM. And it's going to update these 1s and 0s with the result of the operation. Let me take a look. Maybe my CPU is acting up. Not seeing anything out of the ordinary. Thanks for letting me know. Okay. Audio driver's running. It doesn't say I've dropped any frames. And let me keep an eye on that, though. Hopefully it's nothing serious. Hello, Nono. Welcome to the stream. Yeah, please let me know. I appreciate it. Hello, Nono. Cool. So yeah, basically all the CPU does is it reads a pattern of bits, and then that pattern of bits equates to some instruction that the CPU is following, some pattern or operation that's applying to. And then the CPU will read those bits, follow the instruction that it refers to, and then spit out the result back into RAM somewhere. And the instruction typically will also define where the result goes. So basically the CPU is just chugging along through RAM, reading and writing things. And this pointer that tells the CPU what part of RAM to look at to run the next instruction is called the program counter. You don't really need to know or remember this, but just kind of remember the general workflow here of how the CPU works. But this program counter, this pointer, continuously moves forward throughout RAM unless something explicitly changes it. So it'll read this instruction first, and then it'll automatically jump to the next instruction, and then the next instruction, and so on, unless something explicitly happens to change that. So you can think of it as continuously stepping through RAM, working through it instruction by instruction. So it'll say, oh, we're adding this, and we're subtracting this, and we're multiplying this, and we're pushing memory here and there. Thanks for resubscribing, Rox. I appreciate it. Welcome back. Good to see you. Yeah. So basically, a computer is just CPU reading from RAM and spitting things back out from RAM. And pretty much all it does is mathematical operations, adding, removing, subtracting, deleting things from RAM. Where that gets more complicated, and especially with regards to what we care about in terms of how games work, is when you have external peripherals, like, most importantly, the monitor or the graphics card. So let's say you have your GPU here. So your GPU is also connected to the bus, and by the same token to everything else. So what the GPU will do, typically, in a modern architecture, but obviously this is greatly oversimplified, is the GPU will read sections of RAM that tell it what commands to use, and it'll run those commands to draw things to the screen. So it'll say, okay, so this pattern of ones and zeros means draw a blue pixel here. And this pattern of ones and zeros means draw a red pixel here. So by reading those ones and zeros that the CPU puts into place in the RAM, the GPU can render things to the screen. Modern GPUs are very complicated and have basically what are equivalent to a bunch of smaller CPUs within them. But that's kind of the general gist of how it all works. Is everything's reading and writing to RAM. GPU reads the RAM to know what to draw to the screen, and the CPU just does mathematical operations on RAM, adding and subtracting things mostly. So if that all makes sense to you, then we can move on. But basic workflow, yeah. You read the program into memory, the CPU goes byte by byte. You can think of it as going left to right or top to bottom through the RAM, executing instructions. And then GPU or the mouse or any other peripheral also read and write to RAM in order to affect how the CPU behaves. So thinking about how a program would work in that framework, you can basically think of it as every line, more or less, equates to a certain number of CPU instructions. And the CPU is going to do them one at a time, because this program is going to get loaded into memory, and the CPU is going to go bit by bit, byte by byte, saying, okay, let me execute this, and then this, and then this, and then this, and then this, and so on. It just keeps going in a straight line through your code, running one instruction after another. And these instructions are actually way more complicated than just a single byte or so. They get turned into massive amounts of machine code under the hood, but you can still kind of think of it in terms of that same logic of ultimately these are just a series of instructions that the CPU is running one after another, and they read and write from memory to affect how the computer works. So for example, in a really old computer, which this is sort of emulating by using a console, writing some text to the console would look something like a series of instructions to set bits in memory that equate to the display. You would say, okay, I want to set the first block of memory in the GPU to the letter H, and the second block to the letter E, and the third block to the letter L, and so on. So this instruction would actually be a sequence of instructions to take those values and dump them into the console through memory, through the GPU. Now, it's probably kind of confusing, but bear with me here. I'm kind of meandering now. But yeah, the computer runs the command affects memory, and the memory gets read by, in this case, the GPU to render the console. And everything can be broken down into a series of instructions like that. Single commands that the computer is running. We're going to be working mostly with high-level instructions, so you won't have to worry about individual bits and bytes for the most part, but you will need to understand the basic principle, and that's basically all this boils down to, is that the computer does things one at a time. The CPU reads one instruction after another. And so when you write code, you need to think of it in terms of the CPU working its way through the program, one instruction at a time. So when you program, everything is going to be very linear. This thing is going to happen, and that thing is going to happen, and that other thing is going to happen, and there's no overlap. It's always one thing after another in a very precise order. So even though we've got two instructions here, this first instruction is always going to finish completely first, and then the computer will do the second instruction. When you got a really complicated computer, you can end up with multiple threads of execution, is what they're called, where you got multiple CPUs essentially in your computer doing multiple programs at the same time. But we're going to be working purely with a single threaded setup here. So you can think of it just in terms of the one CPU doing one sequence of instructions one after another. So yeah, that is the basics of how computers work, more or less, in a vast oversimplification. So, again, we'll demonstrate what that looks like in terms of Hello World. So I've already run this, but just to show you again. So this is the output. This is what happens when we run the program. But you can see how the program does this. It starts here, and then it runs this first command to write a line to the console of Hello World. And so it wrote that text. And the second line is reading a line of characters from the user input, from the keyboard. So it's waiting for me to type something in. And I can do that right now. I can type something in, press enter, and the program ends because there are no other instructions after this. That's the end of the program. If I were to get rid of this line and run it, the window actually appears and then immediately closes because it runs that command to write the line to the console, and then the program ends. And it's like, okay, I'm done, so I'm closing out, which isn't very helpful. So the reason we have this read line in here, even though doesn't really serve any real purpose, is to stop the program while it's waiting for me to type something in. And that lets us actually have time to look at the result. And it's very easy to change it at this point if we want it to print a different want to write different text to the console, we can change it to say, hello chat. And we just change the text there, run it again. And now it says hello chat instead of hello world. So that's pretty straightforward. We're not going to get too far into how it's doing all of that, but suffice it to say, ultimately, it's writing a bunch of bits to memory and then reading them back out. That's all any of this is doing. So, let's get a little bit more into the most fundamental thing after instructions. So you can think of these as individual instructions to the computer, but that's not very useful because usually we want to do more than one thing. And instructions, with an instruction here, we're always writing the exact same text and we're defining exactly what that text is here. We're saying, hello world. We're giving it a very specific command to write this exact text. But what if we want to write different text? What if we want to be able to change that? Well, we need something called a variable. So I'm going to define a variable here called text to write. And I'm going to set it to that same text that we've been writing, hello world. So in C# land, you can read this as var is a special keyword. That's why it's in this darker blue color. It's a word defined by the programming language to mean something very specific. And then text to write is the name I'm giving this variable. And it's this kind of lighter blue color because it's not a special word that means something already. It's a new name that I'm coming up with specifically for this variable. And then we got this equal sign, which means, in this case, I want this variable to hold this value. And then we're giving it the value hello world, which is text. So to explain a little bit about what that actually looks like in terms of RAM, because that's going to be very important to understand here. So when we create a variable, what we're basically saying is we've got this RAM here. And we've got all these ones and zeros in it. When we create a variable, what we're saying is, I want the program to give me a section of RAM. And I want to call this section by this new name. In this case, text to write. So we're telling the program, I want you to reserve me a block of memory in RAM. And I want you to refer to it by this name. And very good and accurate diagrams. I'm a professional, Moose. And then whenever I use this name in my code, I want you to modify this section in memory or pull it back when I use this name. So instead of saying, I want you to write text to this very specific region of memory, like in C, really old-fashioned like assembly or C land, you would actually say something like, I want to write into memory at this really long address. And you have to give like the specific address or the number of where that memory is in your RAM. And you could read and write values from it. But variables are a much easier way to handle it because you just say, I want to define a variable with this name, and I want the program to handle finding a place in memory and updating it for me. So whenever we are working with this text to write variable, the program is handling actually saving its anything we use with it to RAM and reading it and writing it back whenever we need it. So when we write code like define this variable called text to write and make it hold the value hello world, it's going to go and say, okay, I need some free space in memory. Oh, we do look at that. Here's a nice section that no one's using. We're going to call that text to write. And we're going to, now that you told us to, fill it with this value. So the bits and bytes that represent this text are going to get dumped into the RAM by the program. And then when we use that variable later, by using this name, we're saying, okay, we ran into this name, we know this is a variable. Go into memory and find this variable, and then find whatever value it's holding in memory, and give that back to the program. So if we run this, we get exactly the same result. It says hello world. But rather than the text being part of the program, it's actually being held in memory in its own special bucket for this variable. So you can think of it as basically saying, I want to create a bucket in memory, a variable called text to write. And then it goes and finds a bucket of memory for you to use. And whenever you use that name, text to write, it will pull that value from that bucket in memory. Or if you set it with the equal sign, then it'll save that value into memory in that bucket. So here we initially put the value hello world into this text to write bucket. But then with another instruction, another command, we are putting a new value called foo, or not called foo, but the text foo into the bucket. So now if we run it again, it doesn't say hello world anymore, it says foo. Because when it got to this line, it said, okay, well, let me look up what text to write is in memory. And okay, so now it's got this new value, foo, instead of the old value, hello world. That got overridden because the bucket is now holding a different value. So it may look like this is just a longer way to get the same result, but it's really important that you understand how this kind of bucketing works, because lots of programming depends on the dynamic behavior that this allows us to use. So you can think of text to write as a bucket, like in Minecraft. And it holds a value, in this case the text that we defined. And what this command is doing, this var name equals value is doing, is defining that bucket in memory, creating it essentially. And then we can hold values in it and get those values back out and use them in places. So let's see a very practical example of this. So this is going to be a little bit more complicated, but bear with me. Hopefully you can follow along. So we've got this read line command that we've been using, and what it does is it gets some text from the keyboard and then does something with it. So what we can actually do is take the text that the user writes, and using the equal sign, we can put that value into a bucket, into a variable. So we can take our text to write bucket and make it hold the value of whatever we read from the console, whatever the user inputs on the keyboard. And then we can, using the same command we did before, dump that text back to the console. And then we'll put on another read line at the end just so it pauses and doesn't immediately close on us. So now if we run this program, it says hello world, which is what we do immediately. We create the bucket, text to write, hold the value hello world, and then we write that to the console. And then next we update the bucket again, the variable text to write, with the results of reading a line from the keyboard. So right now it's waiting for us to type something in, so it's stuck on this part. So now if I type something, hello chat, press enter, it took the text I entered and put it into this variable. And then it wrote the variable text back to the console. So we end up seeing the same text that I wrote show up twice. The first time when I typed it in, and then the second time when the program wrote it back out to the console again, using that same variable. So the text I wrote is now being held in this variable, and when we used it again, it remembered the new value that we put into it and wrote that out. So this is kind of a very basic example, but we could do something a little bit fancier now. So let's say you want the computer to say hello world, or hello to the specific person writing the program. We could write something like that. So the way we'd want to do this is we'd want to ask the user for their name, and the user should have to type their name in, and then the computer can say hello name, hello back to the person. So the way we're going to do that is we're first going to create a variable. We're going to call it username. And we don't, we know the user is going to have to type it in. So we can do console.readLine, same as we did before, to have the computer wait until the user's typed something in. And then we can save that value into this variable. And then we can, once we have their name, we can write something back out. We can write hello. And then we want to put their name in here as well. So what we can do is we can combine this text together. It uses the plus sign, but it's not mathematical addition. It's combining the text into one longer text. So if we say hello username, and then plus exclamation point, that's basically saying we're going to write a line to the console, which is hello, and then we'll add whatever is in this variable, this bucket, afterwards. Then after that, we'll add an exclamation mark for good measure. And finally, another read line just to keep the console from closing. If I run that, console opened up, and nothing's printed in it because it's currently sitting here, waiting for this to finish. So I'll give it a name, Hawkbar. So it took that name that I entered, put it into the variable, and then it wrote out to the console, hello, and then pulled that value from the variable, Hawkbar, and then added the exclamation mark at the end. So it says, hello, Hawkbar. And now we're waiting for any user input before we end the program. So you can see how you can make a game with this pretty easily, because now that we have a way to know what the user's typed and look at that value and use it in places, that's basically the basis of game programming. All game programming can be boiled down to sitting there, waiting for the user to do something, and then doing something with the inputs that they send, the commands that they send, and then modifying memory so that the GPU will render a new scene based on the user input. Like even a real-time game, you can still think of it in terms of it's sitting there waiting for the user to press things on the controller. Like say you're on a menu You wait for the user to press the A button to select a menu option. And then the program does things based on the user pressing the A button, like switches to a different menu or selects an item or a skill, and then plays animations, and then goes back to another menu while it's waiting for user input. More complicated games obviously do things while the user isn't inputting anything, but that's the basic idea. There's this kind of loop going on of the user puts things in, and then the program does things with user input, and then it renders a new screen. So yeah, that is our basic hello world. Now let's see if I can get debugging to work. I think it should just work out of the box, but let me check. Perfect. So this is going to be a very useful tool for understanding how a program runs in a very specific way and what it's actually doing. So we're launching the program in debug mode. We did that by setting this breakpoint here, is what it's called, a breakpoint, but it's basically a place for the program to take a break, to stop, and let us interact with it in a more controlled way. So the program started, but it stopped on this line because we set a breakpoint. And we can see currently we've got this username variable, but it doesn't have any text in it yet, because we created the variable, but we're not actually assigning any value to it yet, because this hasn't happened yet. But now, we move on, we type something in, test. So now the program has moved on to the second line, and we can see now that our username variable is holding that value that we typed in. And you can see there's still nothing printed to the console. There's no hello yet, because this command hasn't run yet. But we're about to run that command. So we'll step over that. And I can see now the console's written out. So doing this debugging workflow allows you to go through the program step by step and see exactly what's happening and see what your variables are holding at any given time. Because if you just sit there and let the program run all the way through, it can be very easy to lose track of what commands the computer actually ran and in what order, especially with more complicated programs. But ultimately, keep in mind, all it's doing is going command by command, doing certain processes. So it did this command first to get the input, and this command second to write it back out to the console, and now it's waiting for this command to finish the program. So the way you do that in VS Code is by clicking on this little column here, these little red dots, to set a breakpoint, a place where the program is going to stop and wait for you. And then over here on this Run and Debug menu, you press the green arrow, and that runs the program. And if you have any breakpoints, any of these red dots, then it'll stop there and wait for you. And then you can press step over, step into, to have it go from step to step, line by line. So that's going to be very helpful. So that's the basics of Hello World and variables. Hopefully you've been following along so far at this point. If not, feel free to ask me for additional clarification. I could try to come up with some other analogies that might help explain better. But we've got one more assignment for this session. And we're going to talk a little bit more about variables and how variables work in programs. So if we do this step debugging, you'll see some very important thing here. This is our set of variables here. And we've got this username variable that we created using the var keyword. But you notice here there's this thing that says string. So string is basically the programming term for a text value for very complicated legacy reasons. But basically it stands for a string of characters, like a sequence of characters that are all stuck together, like text characters. So whenever you see string, you can just think text, text value. So hello here is a string, and this exclamation point is a string, and the value that we're reading from the keyboard is a string. It's a string of text characters. So currently our username variable isn't holding any. It's holding what's called null, which basically means nothing. This doesn't have anything in it. But then as we go through the program, we type something in. Now our username is a variable that is holding a string, and the particular string that it's holding is test, sorry. And the reason that's important is because a variable can only hold one type of thing at a time. In this case, our variable is a string variable. It holds string values and only string values. The more proper way to write this would be to say string instead. And this is the exact same thing, but it basically means this is a string variable instead of just a generic variable. And this variable only holds strings. And that's really important when you're working with lots and lots of different values, like you have both numbers and text, and you don't want to accidentally add text and numbers together in a way that might break your program. You always want to know whether something is text or a string or some other type of thing, and you want to be able to keep track of what they are so you don't accidentally break the computer by trying to do things that those types of objects shouldn't be able to do. That's kind of confusing. But like, say if you were trying to like divide 7, the number 7, by the string 3, the computer doesn't know what to do with that, and it's going to give you something really weird and random. You would have to add 2 numbers together. I can actually demonstrate that. So say we have a string variable called b, and it's holding some random text. In this case, we'll say foo. And we've got an integer number variable called a, holding the value 5. And same thing, these are both variables. And this first word is basically just saying what the type of the variable is, what type of value it holds within it. In this case, this one's an integer variable, so it holds a whole number, like 1, 2, 3, 4, 5. And it can't do fractions, but most of the time you don't need fractions. So you'd use an integer variable. And this is a string variable. It holds text, so in this case it's going to hold the value foo. But say you wanted to do something like write line to the console, b divided by a. So what is a string? What is text divided by a number? Well, that doesn't make any sense. That wouldn't do anything. Well, technically, they're all just bits, ones and zeros in the computer, so it might do something, but it's probably not what you want it to do, and it's probably not what you're expecting it to do. It's probably a bug in your code if you're trying to do that. So because we've said this is a integer variable and this is a string variable, the program knows, hey, that doesn't make any sense. You can't divide a string and an integer. That's not a thing. So it's going to helpfully yell at you that your code is wrong and you need to fix it. And it's going to give you this nice little operator / cannot be applied to operands of type string and int, which it's going to be a bit confusing at first, but you can get the gist from it. Okay, there's something wrong with dividing here, and string and int seem to be the problem, that our integer and our string don't work with dividing. This is really important. Early programming languages didn't have this protection, and it caused all kinds of problems. So, because it's very easy to do something like that instead by accident. Say, okay, if I divide it by 2, that makes sense. That's a thing you can do. But no, this one's actually text, and that's still a problem. So it's important to keep in mind what the types of your variables are, what types of values they hold, whether that's an integer number or a string of text characters or anything else. Almost all modern programming languages use what they're called types, use data types for their variables. And you will need to master what the different types are and how to work with them. So I don't expect you to follow along with all of this, but I'm going to demonstrate a more complicated example of how types work in a program. I'm going to write a quick little program that gets the user to write 2 numbers into the console, and it adds them together. So I'm going to write a line here that says, type your first number. And then we're going to create a variable. So what we really want is we want a number, so an integer number. So we'll create a new variable that's an integer called first number. Integer variable called first number. And we want to get that from the console. We want the user to type something in. So just like before, we'll use that readline command. And it's going to complain. Because we're trying to get an integer number, but when you read from the console, you get text because the user can write anything in there. So it's going to say, cannot convert a string to an integer number, which makes sense. You know, the user could type anything in there, and it's not guaranteed to be a number. But what we can do is we can tell it, okay, well, try to convert it if you can. So we're going to attempt to convert it by writing this little bit of line code here. Never mind, that doesn't work in this version. Awesome, they fixed that. We'll call a different command called int.parse. And we're going to wrap this command in this other command. You can see the parentheses. Basically, we're saying do this command first, and then do this other command afterwards. Just like in math, when you use parentheses, it does the inner things first, and then the outer things afterwards. So this is saying, read some text from the console, have the user type something in, and then this command, int.parse, is saying, take the text and try to convert it to a number. So here, if you mouse over it, converts the string representation of a number to its 32-bit signed integer equivalent. So converts it to an int is what you need to get out of that. So we're going to take whatever string the user inputs and convert it to an integer. And now that we've done that, we can store it in our integer variable, and the program doesn't complain about it. So now we should have that in our first variable here. Next, let's have them type in the second number. So I'm just going to copy and paste here because they're doing the same thing. But instead of calling this variable first number, because we already have a variable with that name, we're going to call it second number. But we're doing the exact same thing. We're reading the user's keyboard input from the console, and then we're trying to convert it into an integer, storing it in that variable. And now we want to add these numbers together. So we'll create a new variable called result. That's also an integer because an integer plus an integer will always be an integer. And then we'll take the first number and add it to the second number and store it in this integer variable called result. And then we can put that variable into the console. So let's say result, and then we want to put the result into the text, but result is a integer. It isn't text. It's a number. So we have to convert it into text in order to spit it out to the console. So what we'll do is we'll say result dot toString. And similarly to this command, which converts a string into an integer, if you use a toString command, it converts an integer to a string. Makes sense, right? And now that we have that, we can add it to other text, another string. So when we put all that together, here's what that looks like. I'm going to add a breakpoint so we can step through this line by line and see what it does. So we've got our three variables here. Since we haven't actually assigned any values to them yet, they're just sitting with their default value, which is 0. But we get to the first line, the first command, which is to write that instruction to the console. So look at that. Type your first number. We've run the first line, so now that's happened. We've put that text into the console. And now on our second line, we got a few things going on here. So let's step in. So currently, it doesn't actually show it here, but we are in the read line portion. So it's waiting for us to type something in. So we'll type in a number, say 5. So it took that text that we wrote and converted it to an integer and stored it in the first number integer variable. So you can see here, there we go, it's 5. Oh, this is awesome. This shows exactly what happened. See, so when we read the line from the console, it got a string that says 5. And notice the quotes, because the quotes mean that it's a text string. So it got the string, which has the number 5 in it. But that's not the same as a integer number 5. It's text that has the number 5. So then it called the int.parse command, and that converted it from a string, from text, to the number 5. Notice there's no quotes on that one because it's no longer text. And then it stored it in the first number variable. So next we're going to show type your second number into the console. And there it is. And now it's waiting for our user input again. So we'll type in 3. And exact same thing here. We read the string 3 from the user's input. We converted it into the number 3 and stored it into our second number variable bucket. And now we are going to take the first number, and this variable holds 5, and the second number variable, which holds 3, and we're going to add them together and store that in the result variable. So right now the result is 0 because this hasn't run yet. But if we go to the next line, result now holds the number 8. So it added 5 and 3. We got 8, and it stored it back into the integer variable result. And now we're going to write the result to the console. So we took the string result, and we took the result variable, and before we use the result variable, we converted it to a string with the toString command. Let's see here. Int toString, so result.toString, this toString command, converted the integer number 8 to the string 8. Notice the quotation marks. And then it concatenated, it added those strings together. So we got this string, result, added to this string, 8. And all that got put into the console. So we typed in our first number, 5, our second number, 3, and we got the result, 8. So this is the right way to do it, but let me show you what happens if you don't define your variable types. Because you'd be like, oh, this seems like a lot of work. Why are we doing all this conversion? This just seems like a lot of effort. So let's just make all of our variables these generic variable buckets using the var keyword instead of giving it the specific type. Let's get rid of that as well. So now, if we run this program again, I messed up, give me 1 sec. There we go. We're going to type our first number. So we're going to say 23, or let's say 1. And our second number is 5. So this should be 6, right? Now we get 15. And the reason for that is, when you look at all of our variables are strings. So it took the string 1 and the string 5, because that's what we typed in, and it combined those two strings together, and we got 15, which is not what we wanted. So this is why it's really important for everything to have the proper type. And you keep in mind the difference between numbers and strings and other types of variables. It's more work, definitely, but it's very important for getting the right output and the right result. There are some programming languages that try to gloss things over. They automatically convert text into numbers and vice versa. And it's very easy to accidentally end up with problems like that, where you do the wrong operation on the wrong type of thing, and you don't even notice because the program doesn't tell you. So it's very important that we always define our types for our variables. In this case, integer. And whenever we have a string that we want to convert into an integer, then we need to call some command, we need to run some command that will convert it into the proper type. Just if anyone is curious, if you try to write something that's not a number into this, and the program crashes. But that's a lesson for another day. Input string was not in the correct format. But for the sake of these exercises, we can assume that the user will always type in actual numbers and the program will crash as a result. But maybe we'll talk about that in a future lesson. So that is the basics of programming, basically. It's all about putting values into variables and pulling the values back out and using commands that push things to the screen, commands that check the user's input. And it's just a continuous loop of this. All video games run on something that's basically along these lines, that it'll check for any user input and then do different things depending on the user input, and then spit the result back out to the screen somewhere. So for now, you can pretty much just follow along, copy and paste the example code, or just look at my screen and try to follow along. But in future exercises, we'll go a little bit more into the actual syntax and what all of the different symbols mean for how to write proper code. Like there's all these keywords here, namespace and class and static and void, but you don't need to know any of that for now. Just know that those have to be there for the program to run and focus on this part. And yeah, that concludes session 1. Thank you all for being here. I'll put this VOD up on YouTube later for those who weren't here live, who want to follow along. There's also session 0, which has all the setup instructions for how to download and install all these programs to get to this point. So make sure you follow along there if you want to follow along with the course. And for those of you who are here live, I'm going to switch to a game in a minute. So if you want to stick around, you don't have to go anywhere. We're moving on to something a little bit more exciting.